All right, thanks everyone for coming. Wanted to fit one more of these in, and I had the idea to kind of do a little bit of a themed one. This will be a little bit different than some of the others, less data, maybe a little more stories. Um, I'll say up front, I'm not an expert on all these things, so some folks may have heard things differently. Feel free to chime in and correct me. But this is based on what I've seen, what I've known in terms of the various historical things. This is what I'm calling this old Santa's house that Santa's showing off his remodel. Okay, so I'm going to start with a little bit of geography and mythology, as I call it. North Pole. There's actually different North Poles. There's the geographic North Pole. There's the geomagnetic North Pole. And this is basically assuming you have like a magnet at the center of the Earth. And so that's what the magnetic field was oriented to a magnet at the center of the Earth. That's the geomagnetic field. The magnetic field is where the magnetic field goes straight, points straight down. So effectively, and again, I'm not an expert on this, but basically, it's not like there's a magnet. The center of the magnetic is not at the center of the Earth. It's a little bit off filter. And so that's why you get different things. The magnetic pole actually has been really kind of on a runabout here. It's really been moving very quickly. For many years, it was kind of in the Canadian archipelago. That's this along here, kind of and drifting slowly, kind of northward, and then it really picked up pace starting like 2000, and it's all over here and now on the other side of the geographic North Pole, which is the axis of rotation of the Earth. And what I'm going to talk about today is focused on the geographic North Pole. I'm not going to talk about these others. You're sure well aware, but I always think it's kind of nice to visualize this. The North Pole is basically in darkness 6 months of the year and in daylight, 24 hours of daylight, 6 months of the year. So that's the most extreme. You have the sunrise at the spring equinox and then sunset at the autumn equinox. So this is an image I grabbed from this website I just happened to find. And you could actually put in the date and time, at least to the nearest hour. So this is exactly how it looks a few minutes ago anyways. And you can see the entire North Pole area is in complete darkness. So.
The sun sets around October.
Well, so at the pole, it is September 21st or whatever it's at the equinox. And then, sunrise. And, you get a lot of, the twilight kind of, so there's still some light there, but,
And even on 21st, it's actually a little rising because of the half degree of refraction.
Well, yes, good point, Mark. Yeah, there are atmospheric effects that make some difference there.
But that's a wonder.
Yes, yeah. In terms of the pure geometry, it's.
Yeah.
So North Pole is within an ice-covered ocean. It's in the center of the Arctic Ocean. This is the recent sea ice index on the left here, showing with the ice cover. That's the extent. So there's some concentration variability. And then our motion product, I was from a couple weeks ago, but showing the motion vector. So the ice is almost nearly constantly in motion, and that kind of presents a problem for Santa in his workshop in his house. How does he do that when you are on a shifting set of sea ice? Well, it's obvious, it's magic. Yeah, it's also magic in the right there. You can see there's daylight at the workshop where it should be really dark, but there's, I don't know, some local magic there that gives some light to work with. Kind of moving on to mythology. Way back in the ancient Greeks, there was this idea of the Hyperborea and Hyperboreans that lived in the far north. This really wasn't, as I understand it, was like really the Arctic per se. It was kind of the far north of what their known world was at that time. But they had this mythology, the Greeks were good with mythology, that there was this region in the far north, where these Hyperboreans lived. Boreas meaning the god of the north wind, so that's where that's where you get, Aurora Borealis and so forth. But interestingly, the belief was, even though it was in the far north, the environment was believed to be sunny and warm, and kind of shielded from any cold by mountains. And so it was like kind of a tropical paradise in some sense, at the North Pole maybe. But this was, again, all basically mythology essentially. But this kind of idea kind of persisted. This is a map from 1595. This was Mercator. Mercator of the famous Mercator projection. He actually did do polar projection maps. This is one. But there was not a lot of information known. So that map, as you can see, is probably not very accurate. There's a continent kind of in the middle of the Arctic Ocean there. But it actually persisted, this idea of an ice-free Arctic Ocean, a warmer ocean, persisted much longer than you might think. This is 1872 map produced by the Navy. This is I believe, a Mercator or close to Mercator projection. It's not the greatest, but you can kind of see the red being warmer, blue being colder or ice covered, and there's these channels here. This is basically the Gulf Stream. This does to some extent exist, but they have it going all the way up north, and then also particularly in the Pacific side. So there's this thought that you had these warm currents, the Gulf Stream or the Curcio and the Pacific, and that these warm currents would kind of go up, and they kind of go like underneath, like they knew there was ice there. I mean, whalers and so forth were up in the Bering Sea. There was obviously ice, but the thinking was that maybe you could, if you get through that ice, there'd be this warm pool of water that would keep things ice free. There have been many attempts to try to get through the Northwest Passage over the years. At that point, still hadn't been successfully traversed. That's through the Canadian archipelago. Always found it to be ice choked. And they're, always trying to find this shortcut between the east and the west. And so there's, again, this belief that there was maybe these channels of ice that you could get through. And so this led to a quest for the North Pole. And I'm speaking here, I want to make clear, this is kind of the Western European American goals of getting conquest and exploration. Native Indigenous communities have been living up there for thousands of years. This was nothing new to them, and they were well familiar, well adapted to the conditions. And so this is kind of, again, like the discovery by the West, so to speak, not and only the West. So there's a lot of tales of exploration in the polar regions, in the Arctic and the Antarctic. A lot of the Arctic ones focus on the Northwest Passage. That was a lot of the exploration, but there did come a turn towards the North Pole as basically another route, like I talked about, that it might be ice free. And this is an expedition that I learned about when I was at the Naval Academy many years ago. And it's the USS Jeannette. It's kind of underappreciated, I think, in some ways, and it's not all that well known, certainly by the larger public. But it was a U.S. Navy expedition. They were aiming to get to the North Pole. There was the belief, they were using the belief that there might be this warm pool of water. They sailed in through the Bering Strait and got to like Wrangel Island and a little bit farther, and then the ice closed in, and they got frozen in for a couple of years, and eventually the ship got crushed by the ice. So there's a picture of the drawing of the ship crushed by the ice. They abandoned ship, and they were not super far from the Russian coast, the Siberian coast. So that was where they were trying to get to. So they were pushing their boats over the ice. It was still frozen, and they got to the summertime. You got to open water. There was 3 boats. They piled into the boats in different groups, and as they were cruising along, a storm came up, and one of the boats, I think they were all tied together, but one of the boats broke away and was never seen again, never recovered. But 2 of them that did reach land, but they became separated. and they landed on opposite sides of the Lena River in Siberia. The one side had a village not too far away, and that group made it to that village and were rescued. The other side was desolate. There was nothing there, so they did not make it. And that included the captain, who was DeLong was his name. So anyway, it's really pretty interesting story. It's if you ever go to the Naval Academy, they have a museum there that has a nice display on this that includes these images. And there's the cemetery at the Naval Academy that has this kind of cool, maybe a little hard to see, but there's a cross there. It's a memorial to the Jeanette. And again, it may be hard to see, but there's icicles hanging off the cross, the memorial. And recently, relatively recently, Hampton Sides, who's a pretty well-known author, has done a lot of various nonfiction expedition books and things like that, wrote about this called In the Kingdom of Ice. And it's a quite good book. It really goes into a lot more detail than I'm going to go into here. But if you're looking for a good exploration book, that's not a bad one to check out. So the Jeanette, though it was tragic, and 20 of the 33 died, it actually spurred on some really key exploration and actually science. Because what happened was, and it's probably really hard to see on this map, but this is an old map. There's this like really right here, red underline. You can't read it, but that's the Jeanette. That's where the Jeanette wrecked. And so yeah, they tried to get to the Lena River. But if you look at this little plus, these little plus lines, that's like kind of like the dotted line. The wreckage drifted with the ice, and they discovered wreckage. Europeans discovered wreckage along the coast of Greenland and Svalbard. I forget exactly where all, and that revealed that there's this large scale circulation in the Arctic in the sea ice, and that it drifts from one side of the Arctic to the other. That had previously not been known. I mean, they knew that the ice moved with winds and currents, but that there was this what's now known as the transpolar drift stream. And this guy Nansen, Fridtjof Nansen, he figured out, or he realized, like, hey, I could take advantage of this. I just need a better boat. So he took the Fram, which is there on the right, and sailed it in and froze into the ice and drifted with the ice. And the thing that was clever about the Fram is, most boats kind of have a V hull, most ships, and that's great for sailing on the water, but the ice closes in and crushes it. Well, the Fram is U-shaped. And so what would happen is when the ice closed in, it would kind of go up it would just hit the boat, and the boat would just lift off the ice. It wouldn't crush it. And so it was really a pretty impressive design at that time. It was also double hulled, I believe. And it's actually there's a museum in Oslo that has the Fram there. You can actually go see the Fram.
Molly said she felt the Chowan Way, but Molly said she went there.
Okay, yeah, I've been there too. It's really quite fascinating. So the Fram, they went in. It was a 3-year expedition, and one of the aims was to try to get to the North Pole, but it was actually really very much a scientific expedition as well. There was a real goal of getting a lot of science data. So they were taking weather data, getting water samples and so forth. And but as they drifted, but kind of by the pole, they were going to miss the pole. And so Nansen did decide he wanted to try to get to the pole. So he jumped out basically and tried to ski to the pole. And he left the ship in the hands of his second in command, who was Sverdrup. You may know Sverdrup as the units of transport. And so he tried to ski to the pole, but the drift was kind of going, and he was trying to get to the pole, but the drift was pulling him away. And so he didn't make it. So he ended up skiing down to Greenland. And I didn't check this story, so this is going from my memory, but I believe he basically found a settlement along Greenland in the Ellesmere, I forget exactly where. But he survived and was, found someone, and then got a ship back to Oslo. Meanwhile, the Fram was, drifting through in the ice. It came out of the ice, no problem. Went back to Oslo, And I think they arrived within a couple days of each other, which is really pretty funny, so.
How many people were with him skiing?
I think he had at least one other person. I forget how many exactly went. I know he didn't go by himself, but it was a pretty small contingent. Yeah. I think he didn't want to risk a lot of other lives. So I don't think it was many, but I'm pretty sure it was at least one other, but I don't remember.
He also skied across Greenland.
Yes,
The
yes,
whole- Like all of it?
A lot of it apparently, he was the first to do it, right?
Yeah.
He was also a Nobel
yes.
laureate.
Yeah, I was just gonna
Quite the
mention,
dude.
yeah, he was quite the amazing guy.
Scientist.
Yeah. Yeah.
Humanitarian.
Yeah, I think he helped settle like the Russia-Japanese war or
We
something.
solved 10 wars.
Yeah. So anyway,
The good ones.
yeah.
So we
But
actually solved them as opposed to just let us solve them.
yeah, let me see.
Yeah, the one between Azerbaijan and Hasidim.
Yes, Andy says he has to ski faster. Yeah, to ski faster. So yeah, so this, I think, I would say that in terms of science, this was like the real first scientific expedition in the Arctic. Most of the expeditions, they did take weather observations and so forth, so there was some useful data that was collected, but most of the previous ones, or maybe all of them, were like, looking for glory, trying to find a passage through the Northwest Passage or reach the pole. This was one that was, a major part of it was to try to get data and science out of it. So that he didn't make it, but there was this race to the pole. There was also a race to the South Pole kind of going on at the same time. And the two figures for the North Pole are Frederick Cook and three figures, I should say, Frederick Cook and Robert Peary and Matthew Henson. One of the problems we have with the North Pole that you don't have with the South Pole, in the South Pole, you can go get to the South Pole where you think it is, you plant a flag or whatever, and people can come and they can see it. And it does move, but it moves slowly. And that's where Amundsen planted the flag at South Pole and Scott saw it after a month later and knew he had not made it first. Well, you can't do that in the Arctic. You can plant a flag, but it's going to disappear pretty quickly. Or it's going to move away pretty quickly and probably disappear because the ice is going to shift and it's going to fall in a lead or something. But anyway, these were the three characters that were involved with this. Peary was the first one to make his claim, even though he reached it like a year later. Cook basically reached the pole, came back and kind of went off and did some things and didn't really announce it until later. And they announced it within just a few days later of each other. So then there was this big controversy, like who actually made it to the pole first. And one thing I'll say here, as noted here, both of them, Cook went with two Inuit companions. And that was very much intentional because in that worldview at that time, the Inuits didn't count. So Cook was the first person to the pole. Peary did essentially the same thing, although he brought Matthew Henson along, who was an African American. But again, at that time, that thought was he didn't really count. And so they knew that they would be the ones to make it. If you go with other white men, that may not happen. Now Cook's, his thing kind of fell apart, although it's unclear. I'd say, everyone now, or most everyone believes he did not make it. But a lot of it comes down to Peary really assailing his claim. Like he was very forceful in saying, no, he did not do it. I did it. He had the New York Times on his side, and the New York Times published some stuff. But really, Cook kind of shot himself in the foot too, because he was found lying about somebody what was then called Mount McKinley, Denali. He was later arrested for bank fraud. So it's like if you're trying to build trust that you're not a liar, he didn't do it. So that claim is pretty much gone. There was the two Inuit companions that were interviewed, even though they were not necessarily be trusted, but they both testified they actually never lost sight of land. And the North Pole, you reach the North Pole, you're not going to see land. Peary and Henson, is a little bit, I'd say, still undetermined. But there's a lot that doesn't really add up. They claim they made a lot of distance and covered, like pretty unrealistic, like, trying to jog. But Perry didn't allow the records to be independently assessed. And so there's really a sense that they probably didn't make it, although they might have come pretty close. And if they did reach the pole, it seems like Henson was probably the one that was actually there first. There's a story that like they were going around and Henson was ahead, and they measured things and like Henson's like, oh, I think I'm at the pole now. And Perry's like, was a few hundred yards behind or whatever, and he's like, ah. So he was not happy about that. And Perry, as I was looking at things, like he was just really not a nice guy, and not just kind of a scoundrel kind of a guy. And actually, in terms of accomplishment, Perry was not in great physical shape even, so he actually kind of rode the sled mostly, whereas Henson was the one that did most of the logistical work. He handled the dogs. So really, if you're going to give it to one or the other, it's Henson. For many years, that was obviously not the case. That's now kind of been changed. Henson went back. I think he got a civil servant job somewhere in DC and was pretty much unrecognized for many years until later it started to come out. So anyway, so those are both kind of dubious claims. So who really did make it? Well, Richard Byrd claimed, and Floyd Bennett flew over by airplane, and you could say, okay, does that really count? But you're still over the North Pole. But even that has been disputed. They had engine troubles. They claimed they made it to the pole, but it doesn't seem like they really, the state of the airplane was not going to allow them to reach that far. So I think a lot of that is kind of disputed and kind of doubted now. So the first one that we really have good confirmation of is Amundsen, Raoul Amundsen in 1926 flew over with a blimp, an airship. And with Umberto Nobile and Lincoln Ellsworth. And that one's pretty well verified. So, it's interesting. So Amundsen was the first to make it to the South Pole. He was also the first to traverse the Northwest Passage, and he probably was the first to actually go over the North Pole.
He saw 12 wars.
Yeah. I actually got him mixed up as I was thinking about this initially. I thought he won the Nobel Prize, but it was actually Nansen. But and then there was a couple airplane. There was an airplane on Valery Chakalov. The Russians were big in the Arctic, as you'll see. And then the first to actually kind of step foot on the pole, Alexander Kuznetsov, flew to the pole. And it led a crew of people that flew the pole and landed and set foot on the pole. So that's the official first one. Joseph Fletcher was the first American. I think for many years he was deemed to be the first person. The Russians did not share a lot of information, but I believe now Kuznetsov was beat him by a few years. But Fletcher was the first to and his crew and to make it to the pole. So that's flying. I don't know. Maybe that's cheating a little bit. But so who actually got to it? Going across the surface. Ralph Plaisted in 1968 with snowmobiles, some machines, and 3 other colleagues. This was verified by the Air Force. I'm not exactly sure how they verified it, but that's what it says. And so they're the first one to do it. Now, the first one without power was Wally Herbert and 3 others. So they did it without mechanical assistance. They skied to the pole, but they did have dogs, and there were supply drops as well. So they had some assistance along the way. They actually made it to the pole on the way all the way across the Arctic. The first to go all the way across the Arctic from Barrow to Svalbard, and then the first that I could find, again, there's a lot of firsts that you will find when you do these, but I think this is the first one verified by ski, unassisted. So Bjord Osland and Erling Kage of Norway they put all their supplies, they skied and towed all their supplies the entire way to the pole. And they're the first to do that, and then Uslan did it 4 years later by himself, so, yeah.
How long are these expeditions?
Yeah, good question. I believe, I should have put that in, but too many words.
I know that, her was about 2 years. It was the British Transarctic.
Yeah, it was British Transarctic. Was it that?
I was actually Roy Fritzner's field assistant in 1983.
Okay,
Doing mass balance surveys of Canadian Arctic glaciers and ice caps. This was a person completely impervious to cold.
yeah,
Absolutely.
wow,
Amazing.
Yeah.
And even then, you like looked like this old dried up prune.
Yeah.
He was something like 80 then, but
okay,
yeah, amazing
Wow.
dude.
wow. I remember the Uslan and Keg, I think I remember something like 58 days.
Yeah.
I'm not positive but that's about kind of what it would be if you were like just skiing to the pole, if you have good conditions, so. Some Marines have made it there. Hubert Wilkins, was an Australian. He tried to make it with a submarine way back in 1931, believe it or not. But it was an old decommissioned US Navy sub, and it was his goal to take a sub underneath the ice. But they ran into mechanical problems and other things, they never made it. In 1958, the Nautilus, the USS Nautilus cruised under the pole. They transect under the pole, but they did not surface. The skate, about 6 months later or so, did surface, and there's the picture of it surfacing at the pole. And supposedly, Wilkins' ashes were spread at the pole when they surfaced, because that was his like dying request or last request. So, I don't know if that's true or not, but that's what.
And remember that Fred McLaren, who was here, he was the first to use the upward looking sonar data from the Nautilus.
Okay.
He provided some of the first under ice
Yeah,
information on thickness distributions. He
Yeah.
was a postdoc here.
okay, oh, wow, cool. We'll talk more about the subs and some of the sub data. I wanna briefly step away. I said I was gonna focus on the North Geographic Pole, but there is another Arctic pole, that's of interest. It's called the Arctic Pole of Inaccessibility. And this is the location in the Arctic in the Arctic Ocean that's farthest, as they define it, is farthest from land. There are various poles of inaccessibility. You can do it on a continent, farthest from ocean. So this is the pole farthest from land. And in 2005, 2004, 2005, this guy, Jim McNeil, approached NSIDC. He actually came and visited us here. I remember Ted Scambos, Terry Duran, and I met with him, and he was interested in, he's interested in getting to the pole of inaccessibility, but he's also interested in trying to collect science data as well. So he was, talking to us about what kind of data he could collect, that would potentially help science he could provide to NSIDC. And so it was pretty interesting to talk to him. He did do an attempt, he had a group, it wasn't him solo, but did an attempt in 2006, but they had turned back because of health issues, I think fairly quickly, unfortunately. And then another attempt in 2010 that they ran into ice, that the ice was breaking up, and they just couldn't do it. One of the things that came out of this was that the pole of inaccessibility had been known, the location, or at least it thought it had been known, but Terry and Ted, using some imagery and so forth, and looking at high resolution imagery, discovered that it was a different location than what people had thought it was. I think mostly the little DeLong Islands, which was actually named after the captain of the Jeannette, which is about where the Jeannette was crushed. Those had not been discovered at that point, and people never corrected that. So they actually derived it was off by about 200 kilometers. And then they looked at it again a few years later with the Scott Polar Research Institute, and they found a small adjustment, like a small area, a couple kilometers really is all it was. But And then they published that in Polar Record. And so it's about 85 north, 176 east, and it's just over 1,000 kilometers from any land. So, Jim McNeil was unsuccessful, but I didn't know this, I hadn't heard about this until I started preparing this talk, that it actually was accomplished in 2024. You might expect an arduous journey, very harsh conditions, obviously many deprivations. Well, it wasn't quite that bad maybe, because they actually they made it with an icebreaker. Maybe you consider that cheating a little bit, but still, it's a long way, harsh conditions. This is this French icebreaker, Le Commandant Charcot. And you actually look into it, it's really maybe not that arduous or harsh or not very deprivation. So nice staterooms, nice wine glasses, and please look out. So it was basically a luxury cruise liner that went there. I didn't see, I'm sure it costs many tens of thousands of dollars for people to do that. I think there was some science folks on it, but I'm not sure who. Let's see. Oh, here, Andy says Wally Herbert's expedition was out for 476 days. And he also passed on the obit for Fritz Kerner. Okay, nice. Thanks, Andy. All right. Oops. Oh, yes, I forgot that. They even had a boutique. Now, and it's not a gift shop. It's not like a clothes store. It was a boutique. They made sure that was the word for it. So, okay. So now a little bit of research and some data, get into that a little bit. In terms of the North Pole, as far as research, it's really the Russians that were the first in terms of really intensive and I would say the longest. They had these drifting stations that they would put out. The first one was 1937. Then they didn't go back for several years. I don't know, there was something going on between the late 30s and late mid 40s or so. But then eventually, starting in 1954, they had another one in the early 1950s, North Pole 2, and then 1954, continuously drifting stations. They basically would start out at or near the North Pole. Of course, then they drift. So they didn't stay at the North Pole for very long. It wasn't permanently at the North Pole, but they would drift, and they collected these data. And then, in 91, the end of the Soviet Union, it stopped, and they have revived them. This is something actually I didn't know as well. They started reviving them in 2003. I think more recently, they've actually started to use ships, icebreakers, and freezing in an icebreaker because the ice conditions are really not stable enough to have a long-term platform or anything there.
So
So
we have those data here at NSID.
Yes.
I think we do.
yes, I'm
Sorry.
that's okay. Spoiler alert. No. Yes. So when the Russians when that ended, there was the thought, there's some valuable data, and that's a valuable data record. Can we keep that going on the US side? And that was the North Pole, that started the North Pole Environmental Observatory, which is an NSF funded series of expeditions. It's operated at the University of Washington, or was. Polar Science Center, Jamie Morrison was the PI. He's now a member of the ISAT-2 science team. At least he has been. I'm not sure if he officially still is. I think he is. Anyways, and they would go out. It wasn't like the Russians. They weren't sitting. The Russians manned those stations for months at a time. They would have a crew out there. But the MPEO, they would go out there, take some measurements, and put in instruments, and then leave. So they might stay there, I'm not sure how long, like maybe a week or something like that. But then those automated measurements would last, through several months. The data are archived at the Arctic Data Center, which is the NSF Data Center. So there's a picture. They have webcams you could watch. Again, that ended in 2015, which is kind of too bad, but I got 15 years out of it. One of the things they did was they put in mass balance, looking at thickness. You can see here, this is a downward looking instrument sonar. Also, I think they would have albedo and so forth, but they could measure, they put this in, they can measure the height, then they put one underneath the ice and measure the ice there. And so you can measure the thickness and the evolution of the thickness over the course of a year. So I always think this is kind of a neat, not the greatest image, but plot of what they could do. You starting out in April, winter, basically, you have a snow cover, and then you have ice that you can measure the temperature. They had a thermistor string that would measure the temperature, and then you get to the springtime, and the snow would disappear, would melt off, and then the ice would start to melt. You'd also get bottom melt because of the ocean temperatures would warm up. And then you get to like August, which is, winter comes early in the North Pole. You start getting snow cover again, the air temperature would be cool. There it is. But it's interesting, the bottom melt continued because there's the heat in the ocean was still there. So the bottom melt would continue on until I think this is like November or so, and then it would start to thicken up again. And so this is really nice. It shows kind of like the time series of the evolution at a point. And then you can see the melt over they did this for several years. This is 2012, which is the most extreme, a lot of bottom melt and as well as surface melt. So that's one of the reasons we have the record low. And of course, they would drift out as well. So this is kind of hard to see. These are different years drifting from the North Pole out through Fram Strait here. Kind of related to these in collecting data, there's what was called the Environmental Working Group. At the end of the Cold War, 91, fall of the Soviet Union, there was a realization that there's a lot of data. So that, the Soviets did not share their data, not at all willingly. And to be honest, they're still like that, I would say. But there was this kind of, openness that came after the fall of the Soviet Union. And Vice President Al Gore at the time, he realized like, hey, there's some value here in a lot of useful environmental data. And so he talked to the Russian officials and collaborated, and they released these atlases, Sea Ice Atlas and Meteorology Atlas, originally on CD-ROM. And these, included like the Russian station data, with meteorology and all kinds of things in Russian and US ice charts and some of the submarine data, which I'll talk about in a minute. And that is available. It's a NOAA data set here. It's been here, it originally was on CD-ROM. I thought I had these CDs, I was looking for them, I could not find mine. I don't know, I guess I lost them. But you can download it. It's kind of an interesting little data set. You can see what happens over 30 years. Well, I guess some of it was published as late as 2000, but this was really like 95 when they started putting this together. And so this is just a sampling of some of the things. This is like the drifting station track. This is some of the measurements. That's the North Pole 1 on the left there. Takes me back to my USO days. Yeah, for those that are newer here, this the way we distributed data was sending out CDs to people. So and so that was the good old days, so to speak. This is some marine data, and this red outline was what came to be known as the Gore box. They had a negotiation on what data and what regions would be released, and particularly for the submarine data. And so this was the box of area, where kind of encompasses the North Pole and over towards Alaska. Doesn't encompass any of the Russian shelf area because of course, the U.S. submarines were not going over there, and that's their territory. We wouldn't have any desire or reason to spy on them or anything, or try to get anything from them. So it's just that release area. So that leads into SizeX, which is related to that. I don't know if it came out of exactly the same area, but the impetus was the same. The Cold War ending, the Arctic submarines. The Arctic Ocean was a major front in the Cold War. If there ever was a hot war between the Soviets and the U.S., that would have certainly played out part of it in the Arctic Ocean. And so there was a lot of submarine activity, both on the Russian side and the US side. So with the end of that, they decided, we can declassify some of this data. And we could also, they had these submarines, and now we don't need to be defending the Arctic Ocean against the Soviets, the Russians. What do we do with these submarines? I mean, do we just leave them in the dock? Like, hey, we could, do some science with these because they can collect data where you can't normally collect data and much more efficiently. So they came up with this, what they call the Science Ice Exercise or SciEx. These are dedicated science crews. This is pretty amazing. They took on scientists on board. They went under and they collected data in certain areas, not everywhere by any means, but to allow, a unclassified, without a security clearance, well, maybe they needed security clearance. I'm not totally sure. They probably did actually. But, they were not on any kind of defense mission. It was purely for science. So that lasted for a few years and then they ended in 99 as specific science cruises. But since then, they've continued what are called science accommodation cruises, where the Navy collects, there's no scientists on board, the Navy collects the data, they declassify it, they remove certain information that, specific regions and some of the accuracy is removed. And that's all archived at NOAA and NSIDC here. I'm actually on the advisory board for this, although we haven't been very active lately. But for a few years in the mid 2000s after 2010, there's a fair amount of activity. It is a little bit like pulling teeth with the Navy to get data out of them. They take a long time and they tend to be reluctant. And they also are very reluctant on where they cruise and where they collect data and release data from. For obviously good reason. That they don't want to give away any secrets. But there's okay. But it's potentially valuable data, and actually, it really I tend to think from a CI standpoint. Oh, Donna's saying Ann just received some funding, so that's good. Yes, I do remember that now. So there is some support for managing the data, and so hopefully there'll be more data. But this in terms of CIs, this is this Rothrock et al. Paper in '99 is I would say one of the more important in the last 30 years or so, because it took that submarine data and put it together and analyzed it over. There's some data that came as early as the 50s, Mark, as you said, but
Nautilus.
the Nautilus, but it's pretty sparse. So this was from the 70s through the 90s. So this is earlier data they declassified plus the SciEx cruises that they did. They put that together and they looked at the change from the 70s to the 90s, from like about 75 to 95. And they couldn't do like specific overpasses or whatever, so they kind of had to bin the data. But when doing that, it's very clear this is the thickness change or the draft change actually here. So the underwater part of the ice, which is 90% of the ice cover, had thinned significantly in these last 20 years. And this was really the first direct quantitative evidence of large scale thinning of Arctic sea ice. I mean, we knew it was getting warmer, we knew the extent was going down, but this showed, the ice is getting thinner, even near the pole, that the ice was getting thinner. And it's still valuable, even though, now we have altimeters, we have ISAT-2, we have Cryosat-2, so we get much more data from those, covers a much larger area, much temporally intensive, but it helps put that data in perspective. So you can see on the left side here, these they basically did kind of like a smooth fit because there's not enough data to really show specific, but they did basically like a modeling fit. This was Ron Kwok and Sarah Cassimi now helping to take over, but it really shows the recent altimetry data is showing how much lower it is than it used to be, that change. It's continuing on that change from the 1970s from submarines. More recently, we did have an expedition that did make it to the North Pole, and that's Mosaic. And it's the multi-sensor expedition. It was on the Polar Stern. I think I meant to put in what Mosaic stands for, which I can never remember. But it was the Polar Stern. They froze in, kind of similar to what Nansen did with the Fram. It was kind of a similar idea. Drift across. They actually drifted across much faster than they had expected. And so they came out of the ice, sooner. The plan was to stay in for a full year. So they actually cruised back up to the pole, because why not? Well, they had some issues with, this was during COVID, actually, as folks may remember. So there was a lot of problems with that caused some things, and they, had to abandon the ice for a bit as well, but they came back, went to the North Pole, and they sailed up in July in the North Pole. And one of the things that was noted, and this is a really hard to tell picture, but they noted that the ice cover was really quite sparse there. And, it's an icebreaker, so they could get there. But normally in the past, you would have been breaking ice, moving quite slowly. They were able to cruise up through flows of ice with very little resistance. It only took a few days to get to the pole. And then they kind of drifted with the pole for a while longer and then came back out. And so really great. There's a lot of Matthew Shoup here was the US lead for it.
There's a lot of scientists.
Yeah, John Cassano was on it, Julian Struve. I know there were others I'm not remembering. But yeah, so it was, a really successful expedition, and the data is still being analyzed, and there's still a lot of great science that's coming out of that, even 5 years later. This is another one that, in terms of the changing pole, this is on the other side. You can kind of, the lines are really hard to tell, but the North Pole is kind of towards the bottom. But there's a lot of open water there that goes very close to the pole. This was in 2016, which was a pretty extreme year. But we're starting to see this pretty regularly, where it's not like it's ice free per se, but there's the ice is broken up. It's individual flows. You could get through. You still need an icebreaker, but it's a lot easier than it used to be. And one of the things that's changed is the ice age. And this is a DAC data set that I work with. So I wanted to show that. The little blue diamond, like blue diamond is basically the North Pole. And you can see 84, where there's a lot of the older ice, thicker ice has now been lost. And now it's much thinner ice even at the pole. And so looking just in the right around the North Pole, 85 degrees north, the farthest north 5 degrees of latitude, the oldest ice is really, there's years there's none of it in that area anymore. It kind of bounces up as it drifts across sometimes time to time. But you look at the first year ice, the 0-1 year ice is much more dominant now than it used to be. It now makes up close to 50% of the ice cover at the North Pole, compared to, and even, the 1 and 2 year ice, which is a bit thicker, survived one summer melt season. You take those two out and you're down to maybe 20%, 10 to 20% of the ice cover. So a really big change. That implies a big change in terms of the ice of the future as things continue to warm. The climate models are projecting, an ice-free Arctic potentially as early as 2040. Some potentially even earlier, I guess, but I think 2040 is kind of a good estimate. And the North Pole, will probably become ice-free, at least seasonally, at least during the summer, before you lose the rest of the ice, because the ice along the coast of Greenland and the archipelago will remain longer than the pole. And so, the North Pole is fast becoming, on a trajectory to becoming ice-free. If you're a skeptic, you might say that it's due to Rudolph's red nose and the heat from that. But it seems to be more likely to be, greenhouse gas and albedo feedback effects that are causing it. And so with the shifting poles, I'm almost done here. There's a lot of political and economic implications. It's very important for oil and gas, minerals, natural resources, as well as transportation. On the left here, there's kind of two routes across the pole, or across the Arctic. There's the Northwest Passage through the Canadian archipelago. That's the green line. That's still not really terribly viable for shipping or anything like that, anything large scale, because there's a lot of ice that still flows down in there. But the one that is the Northeast Passage or Northern Sea Route, which goes along the coast of Russia, along the coast of Siberia, and that's being actively used. But the Russians control those waters. And so that's, there's various reasons why that may not be great. but there's the cross pole route. If the North Pole becomes ice-free, you could potentially go right straight across. And then you're not in their territorial waters, and you don't need, to go along the Northern Sea Route, you need Russian escorts, and you have to pay Russia for that. And so, there's a cost to doing that. And this gets into, who owns the pole. There's kind of this economic zone area, which is basically the extended continental shelf. I think it's about 200 nautical miles from the continental shelf that you kind of have, each country kind of controls. But there is some debate about these things. There actually is a debate about right here, between the US and Canada, this little wedge. Depending on how you define where the line should come from the coast, whether it belongs to Canada or US. So there's a little bit of fight about that. And then there's these other areas that are disputed, like the North Pole region here, actually, is one of the disputed areas between, I think, Denmark and maybe Canada and then Russia. And
they won in court, by the way.
who won?
Russia did.
Did they? Okay. I hadn't heard that. That's, yeah, appreciate it. Yeah.
Their war won't take place for a while, but it's that long enough of bridge extension.
Yeah.
It's
That's right. Yeah. Yeah. So,
Whose court?
an international court for the marine limits, as I've got information.
Yeah. yeah. So they, folks didn't hear, Art was saying that Russia won in court. There's the Law of the Sea Treaty, which is used to adjudicate these disputes. And these competing claims, so it's somewhat related to that. In the US could fight things in that, except that we haven't ratified it. This is one of the more bizarre things that's been talked about for many, many years. There's like a few people that don't want it ratified for some reason, a couple senators, I think, that hold it up. The US does abide by it in general, but because it's not ratified, we're kind of on the outside a little bit looking in. But in terms of this Russian claim, so the Russians claim, they have this, it's a pretty big continental shelf, so they already control quite a bit. But there's this, what's called the Lomonosov Ridge, which is a ridge that cuts across the Arctic and comes out from the continental shelf. And the dispute is that part of the continental shelf? Is that extending from the continental shelf, or is that something different? And other countries have said, no, that's not the continental shelf. That's just the ridge in the end of the Arctic. And the Russians have said, no, that's extending from our continental shelf. So it's part of our continental shelf. And as Mark said, apparently they have won in court. And so now they can extend that in 200 nautical miles on each side of that potentially. And so, and to try to claim this, if you want to claim something, you put a flag on it. And so they actually they sent a submersible down with a couple people down to the bottom of the Arctic Ocean, which is a few thousand meters. It's not shallow at the pole. And you can see they placed the Russian flag on the North Pole. This was back in 2007. It got a lot of press at the time. And it was kind of humorous, but also in some ways serious, because they were making at least a PR claim on it. So with that, that's all I have. So. And happy to take a few questions. I know we're almost at time.
Did you ever come across stuff on Crockerland?
Crockerland? No.
It was interesting. Crockerland is this island archipelago that Peary claimed to have seen well north of Ellesmere Island, way up north, right?
Okay.
And it was later found that he was confused by a mirage. Okay. However, I have a 1949 Randon McNally atlas that shows Crockerland. Really dark. Yeah.
Okay. Cool. Yeah, Don is asking, haven't the Chinese also started making claims to parts of the Arctic? They certainly have become very active in the Arctic. They have icebreakers. They do regular expeditions up in the Arctic every summer. I don't think they have any rightful claim because they're not bordering it. They're not. Yeah, they have. Yeah. So, but if they collaborate with the Russians, they could certainly work with them. There's the Arctic Council, which kind of is the political organization that helps kind of manage things in the Arctic. And China is an observer, I believe.
Observer
Yeah,
nation,
an observer nation. So the Arctic Council, there's the seven Arctic nations that border the Arctic.
Eight,
Is it eight? Okay.
because of Iceland's little island. that
Oh,
goes in.
Okay,
Sorry.
no, that's good, yeah, I always thought it was seven, but then there are observer status, people with, or countries with observer status, and China is one of those.
Yeah, and South Korea's another one.
Yeah, and South Korea's been quite active as well. Japan is another one that, it does do, some research in the Arctic. So there's definitely a lot of interest, from a science perspective, but also obviously economic, and so, and political. So, yeah, China's very
Right now,
active.
activities are largely suspended because Russia's out. Because of their,
Oh, from the Arctic Council, yeah.
It was really messed things up.
I heard that
They're back at some level.
yeah, they have restarted, yeah, with the start of the Ukraine war. They basically kind of kicked Russia out, and I think Russia had they rotate the chair. Every 2 years, each country controls it for 2 years and kind of set the agenda, like what they want to focus on. And I think Russia had the chair at that time,
Right.
and then that's one of the things that caused the big problem, is they kicked them out, but then they didn't have anyone to.
They're back at some level.
Yeah, they're back at some level. And so there's been some things going on, and they've restarted some things. But that definitely, impeded the work of the Arctic Council. So, yeah. Any other questions?
Cool stuff.
Okay, thanks.
Thank you.
Yeah, happy holidays.
Remove Crawford.